Continuing with 4.5 part 3, let's talk about now the properties of cosecant. So we got y equals cosecant of x, which remember cosecant is a reciprocal of sine. So we actually don't have a new table. We're going to use the sine table to help us graph this. Alright, so remember our sine table. So sine has a period of 2 pi. So cosecant is also going to have a period of 2 pi. And let's use our interval, so halfway between 0 and 2 pi, halfway between 0 and pi, halfway between pi and 2 pi. Sine starts with the origin, and goes up, comes down, and then goes back to the 0. Alright, so when we graph this, we're going to graph those points, but don't actually connect them. Alright, so to scale this. Right, so when we go to graph this here, let's graph those points. Now, just watch up here. So I could connect these points here. Don't do it to yours, just watch this. And that would be sine of x. But remember, cosecant is a reciprocal, and the reciprocal means we're going to flip it upside down. So what happens here is we have a bunch of little parabolas kind of facing each other here. So you can see this little parabola right there, and then I have a separate little parabola right there. So those are actually going to do the reciprocal. They're going to flip. But you got to be careful because remember, so cosecant is r over y. And so anywhere that the y value would have been 0, which is where sine is 0, it's going to cause it to be a vertical asymptote. So the first thing I'm going to do is everywhere that is on the midline there, the center of the wave, the axis there in the middle, everywhere that y value is 0, I'm going to draw in a vertical asymptote. So let me take out my, take out my red lines there. I'm going to rewrite that r over y. Alright, so we're going to draw these in now as vertical asymptotes. Alright, so all you have is your points plotted there. You don't have the blue line. So what you're going to do then is now, because that's where sine was 0, is where my vertical asymptotes are, you're going to take each little parabola here, and you're going to reflect it, or you're going to do the reciprocal, you're going to flip it. So, use the same vertex, instead of this one going down, it's going to go up. And then this point that's down here at the bottom, instead of its little parabola going up, it's going to go down, and both of them keep going. And so that is going to be what cosecant looks like. So what we can do, too big. So we can go through here, I can erase my little blue line, and mine should look pretty much like what yours looks like. Now that's one full period, so it takes a little parabola going up and a little parabola going down to create that full period. And so then you could continue it by just following your pattern. So we can go the next, I can't go to my right, I ran out of room, so I'm going to go to my left. So my first one on the far right went down, then it went up, so go left, so my next one's going to go down. I'll have a vertical asymptote, the next one would go up, just like we did before, just continue your pattern. So for this time, instead of playing connect the dot, I want you to do the reciprocal. So that's what cosecant's going to look like. So now let's talk about the parts of cosecant, or some of the properties of it. So our domain. Again, the domain, because we have those asymptotes, cannot be positive to negative infinity. So we need to talk about where the domain cannot be. So the domain cannot be, find one of your vertical asymptotes. It's at 0. And how often is that happening? It's happening every pi. So x cannot equal 0 plus pi n. Or we could say x cannot equal pi n. Okay, the range. Also does not keep going up or keep going, it does keep going up and it does keep going down. But notice in the middle right there where the sine curve was at, it's not connected right here. So that means that it does keep going down. So it goes from negative infinity and it goes up to negative 1. And then it's going to jump up to 1 and go to positive infinity. Alright, your x-intercepts are your zeros. It doesn't cross the x-axis at all, so it's none. Vertical asymptotes are, again, they are where your domain cannot be, so we know they're at x equals pi n. Is it even, odd, or neither? Well, we said cosine, it is reciprocal of the only even ones. So this one is odd, which again means it's symmetric to the origin. Which also means that if we took cosecant of negative x, it would give us the same value as cosecant of positive x, except it would be the opposite sign. And then because it is the reciprocal of sine, its period is going to be 2 pi.